Good morning guys, and welcome to today's worked exam answer video. Today I'm having a look at a GCSE making salts question, and this particular question has come from an Edexcel GCSE double award paper, but I've seen nigh on identical questions in the AQA papers as well. Now, when we're thinking about making salts, we need to be aware of the different methods of making soluble salts, and then in some instances you may also need to know about making insoluble salts. For this particular question, we're looking at how we can make a soluble salt, and you might be thinking, how on earth am I supposed to know? This question is about barium chloride. How do I know if barium chloride is a soluble salt or an insoluble salt? And there's a couple of ways that we can think about that. The first and perhaps easiest in this particular question is to have a look at the balanced chemical equation they've given us and have a look at the state symbol. So AQ stands for aqueous, which means something dissolved in water. If the barium chloride was insoluble, we'd have an S as our state symbol for solid, but it's aqueous, so this means that barium chloride is a soluble salt. The other thing is there are solubility rules in terms of, for example, all nitrate salts are soluble. So anything that has the nitrate ion in it will dissolve in water. And again, knowing that is really helpful. And there's a few different rules. And for the chloride rule, most common chlorides are soluble, and there are some exceptions to that, which are silver and lead. Barium's not silver or lead, so therefore barium chloride would be soluble. Now this question is thinking then about the method of how we would get dry crystals of hydrated barium chloride. Now that might sound like a bit of an oxymoron or a juxtaposition, because hydrated means that there's water present, but we want to create dry crystals. So when we think about hydrated barium chloride, we're not just thinking about barium chloride that's a bit soggy, we're thinking about water being trapped inside the crystals. So we're thinking about waters of crystallization, where we might write BaCl2 dot a certain number of waters, where the dot shows that the waters are part within the crystals, but not kind of getting in the way of the structure of the crystals. So we keep the formula barium chloride all together, and then we keep all the waters together, and that shows that they are hydrated. So that's the first thing. Usually it will also say describe a method to produce pure dry crystals, and when we're thinking about the purity part, we want to make sure that there is nothing else in the solution with the barium chloride. Water's fine because this is dissolved in water to give us the solution. The gas is going to escape, so that's fine. The HCl, if there was any of that left over, the presence of that would then contaminate our crystals. So in terms of the purity, we want to make sure that all the acid has reacted, and that's going to be one of the stages that I will explain in my method. So we have to describe a method to produce the dry crystals of the hydrated barium chloride, starting with, as we can see in our equation, barium carbonate powder and dilute hydrochloric acid. Now, it doesn't say explain the method, it just says describe. But just thinking about the barium carbonate powder, a connection to thinking about rates of reaction, if we use a powder for our solid, that gives us an increase in surface area, and if we increase the surface area of a solid, we get an increased rate of reaction, which is very helpful. Now there is another way we can increase the rate of our reaction, and that's by warming up our acid, and that's going to be the first thing that I'm going to do here. We're going to warm up our hydrochloric acid to help the reaction go a bit quicker, then we're going to add our barium carbonate powder, and then we'll take it from there. Okay, now you don't have to do these sorts of questions in bullet points. If you've watched my videos before, you'll know that I'm a big fan of bullet points, just because it helps us to be concise and not kind of go overboard and give a load of details we don't need. So we don't need to say, first of all, I'm going to get a Bunsen burner, and then I'm going to get a tripod and a gauze, and I'm going to place the, we don't need to go into that much detail. We kind of have to assume the examiner knows a little bit about what we know. And knowing where that line is really hard, unless you have done lots of questions and you've been using the mark scheme to go, okay, this was the answer that I wrote for this question, and actually I didn't need any of the first chunk that I wrote because none of that was on the mark scheme. Then you know for the next time that you don't need to go about doing that. Conversely, it might be that you then go a bit too vague and then you go, oh, actually, I needed to be a bit more explicit in my answer, and then you go the other way. And that's where using the mark schemes is so important. Okay, so step 1, we're going to warm the HCl in a beaker over a Bunsen burner. And that is going to do for step 1. Step 2, add, and we can use the formula. If you are going to use the formula, don't get the formula wrong. I think it's good to use a formula because it's going to save you time and space. But if they hadn't given us the formula and you weren't confident with what the formula for hydrochloric acid or barium carbonate was, then please do write the names because wrong formula will be penalised. So add barium carbonate powder to the beaker and stir. And we're stirring to ensure that we get as much of the powder reacting as possible, and stirring also helps to collide the particles. So again, thinking about rates of reaction, if we're stirring, then we're going to get more collisions, and that will therefore give us more successful collisions per unit time, or a greater frequency of collisions. Now, in order to make sure that we've got none of this acid left over, we need to continue to add barium carbonate powder until we can see that it's in excess. And how do we know that it's in excess? Well, 2 things. Because we're making a gas, as soon as this is in excess, it'll stop effervescing. Once all the acid has been used up, there'll be no more CO2 made, so there'll be no more bubbles. If we're not making a gas in a particular reaction, how else can we know it's in excess? Well, we'll start to see the barium carbonate powder collect in the bottom of the beaker, and we'll stir it, and then it will just resettle back at the bottom, and that tells us that that barium carbonate is not actually going to react anymore. So again, we don't need to explain the method, we just need to describe. So add barium carbonate powder to the beaker and stir. Next point, repeat until the barium carbonate is in excess. Don't think I'd need to say any more than that because I'm just describing the method, not explaining the method or explaining how I know that something is in excess, but we'd know it's in excess if it stopped bubbling and then there was some excess powder at the bottom. Now, if we're trying to form crystals of barium chloride, we don't want in the flask for there to be the barium chloride, the water, and our excess of barium carbonate. That's just going to get in the way. The reason why we can add an excess of this to the acid is because we can remove it really easily, because this is going to be a solution. This is a solid, it's insoluble, it's not going to dissolve into the water or the solution that's made. Therefore, we can get that out using a filter funnel. So the excess barium carbonate would be trapped in the filter paper, and all of our barium chloride solution will go through into a conical flask. And please don't be afraid in these sorts of questions to draw little sketches of apparatus if it helps you to explain what's going on, or it just helps you to visualize the process. So, next step, filter out the excess barium carbonate using a funnel, filter paper, and conical flask. And we use a conical flask rather than a beaker here so that the funnel can sit nicely in the top of the conical flask, because it's got the slopey sides and the thin neck. When you then put the funnel in the top, the funnel's not going to be rolling around all over the place, which is key. Okay, so at this point, our barium chloride crystals are in the conical flask. And what we're going to want to do then is, first of all, evaporate some of the water so that we get a saturated solution. Then we're going to transfer it off the heat onto a warm windowsill so that remaining water can evaporate, but also as the solution cools down, the barium chloride crystals start to crystallize out of solution because solubility decreases with temperature. And then what we may need to do to get them to be dry is just refilter so that any water that hasn't evaporated is removed from the crystals, and then we can just dab them dry with filter paper. You don't really want to use tissue because that's probably going to get stuck all over them. So yeah, a bit more robust filter paper would work. Okay, so how are we going to explain those steps? First of all, we're going to transfer the barium chloride solution to an evaporating basin, which is one of those white kind of dishes, the deep ones. You will have seen one, I'm sure. And we're going to set up a hot water bath. And again, don't necessarily need to explain the whole process of how to set up a hot water bath. Again, that's probably one of the things that we can assume the examiner knows we know how to do. In case you're not sure how to do that, we can use our Bunsen burner, our tripod and our gauze, and then use a beaker of water and then sit the evaporating basin above the beaker. And it's important we do that rather than just placing the evaporating basin on the gauze, because if we heat it too quickly, first of all, a lot of the water will evaporate and then we're not going to get very big crystals, but also because we're trying to get hydrated crystals, if we warm them too quickly and too strongly, we will lose the water from the crystals as well, which we don't want to do here. So warm the solution gently to evaporate some of the water, and I'd always specify that so that again you're just illustrating that you know we're not going to be evaporating all of the water here, just some. Then transfer the evaporating basin to a warm windowsill where it may get some sunshine. Transfer the evaporating basin to a warm windowsill so the solution crystallizes. And I'm only saying that because in my next step we can only really then filter off any remaining water once we know that we have got all the crystals out of the solution. So that's why I've put that in here. And then we can say filter off any remaining water, and then dry the crystals using filter paper. Now sometimes in these 6 markers you get one of the 6 marks for talking about apparatus, and it hasn't specifically said that in this question, but it's always good to kind of talk about what apparatus you're going to use in different steps. So using the filter funnel, the filter paper, conical flask, starting with the hydrochloric acid in a beaker. We've mentioned a Bunsen burner, we've mentioned the evaporating basin, we've mentioned the filter paper to dry the crystals. that's all really good. I could have said stir with a stirring rod to add another piece of equipment in there if I needed to. And if you are given a list, obviously make sure you use all pieces of equipment you've been given. And there's more than 6 points there. Now, in some of the AQA questions, the 6 marker questions like this one, they're kind of, the mark scheme splits it into 2 levels. It gives you all the kind of content you can include, and then for the highest marks it says, well, you need to include a wide range of these things. So it might be that you include the steps and a number of pieces of apparatus, for example, but there'll be certainly more than 6 points listed. In the Edexcel GCSE mark scheme for this exact question, there will be sort of maybe 6 to 8 points, and then you can get any 6, so long as you've not said anything contradictory or chemically inaccurate throughout. So notice how I haven't used all of the space, quite comfortably not used all of the space. And that still reads as a method that someone could follow, with a little bit of knowledge, I appreciate, in terms of setting up the hot water bath and warming the beaker with the HCl in at the beginning. But again, I think that meets the line of being too explanatory versus being too concise. So let me know what you think, and if you've got any queries about other things that you thought you should have included or might need to include, or things that have surprised you that I've included, please do let me know. And if you've got similar questions that you want me to have a look at, again, just get them sent over to me, guys. Thanks so much for watching. Hope you have a really lovely day.